Now, as we know that atomic size is measured due to the atomic radius of an element. If the atomic radius of an element is larger, then its atomic size is also large. And if the radius of an element is small, then its atomic size is small. To get it, it's a very simple example of normal life. Let's take it. If your friend has a height of 5 foot and 4 inch and you has a height of about 6 foot and 4 inch, then of course your size is greater than that of him, right? Because your height is longer than him. Similarly goes with the concept of atoms. If an atom has a radius larger, then of course its atomic size will be larger. And if an atom has a radius small, then its atomic size is going to be small. Now we'll study the trend of atomic size in S block elements. In S block elements, the trend of atomic size. Trend of atomic size. Atomic size. Now, it is very simple. As we know that group 1 has elements lithium, sodium, potassium, rubidium, cesium and francium. These are group 1 elements. Group 1 elements. And as we know, according to the properties which are in periodic table, that while going down the group, our atomic size increases. It is very simple to understand. Let us take an example of lithium and sodium only. As we see in lithium, the last electron enters in last shell. As we go down the group, the electron enters not in the same shell but in another new shell. Similarly, as we go down the group, the new electron enters in new shell. So as we see, when we go down the group, the electrons that add up, it doesn't add up in the same shell, but it adds up in the new shell. As the number of shell increases down the group, the radius also increases. As we can see, R3, R2 and R1. It's clear from this is that R3 is greater than R2 is greater than R1. Why this happens? Because as the number of shells increases, the distance from the nucleus to the last boundary increases of the atom, due to which our atomic size also increases as we go down the group. Hence, the trends come out to be lithium has the smallest atomic radius because of it has the only one shell, that is its boundary with the set that of nucleus is very low. When it comes to sodium, the boundary increases as the number of shell increases. So as the number of shell increases, its atomic size also increases. And as we go down the group, the number of shells goes on increasing, so the size also increases. Hence, the order of group 1 elements with respect to atomic size comes out to be lithium, then sodium, and then potassium, then rubidium, then cesium, and then francium. This is what we studied in group 1. Now, if we have to take an example of group 2, we need to understand the group 2 elements. For that, let's say group 2 elements. We took group 2 elements. What are the group 2 elements? Beryllium, magnesium, calcium, strontium, barium and rhodium. Now, as we know that similarly here 2 electrons add up as we go down the group. As we go down the group. Here 2 electrons add up as we go down the group. So, as we go down the group, the size also increases because the number of shells keep on increasing. As the number of shell keeps on increasing, the distance from the nucleus to the last boundary also increases, and hence, similarly, while going down the group, while going down the group, our atomic size increases. Atomic size increases, and the reason is because the number of shells increases. Hope it's clear. So the trend in group 2 elements come out to be beryllium, magnesium, calcium, strontium, barium, and radium. Hence, this is the order of atomic size. Increasing order of atomic size in group 2 of S block.